Okay, welcome to 8.5. This is how to complete a square when a is not equal to 4x, or is not equal to 1. So now we've got a number of x squareds. If you think of our tile, we would have 4x squareds, and all that I want you to think about is how would you put those big tiles into a square? And if you say, we'll just make a square of them, you're exactly right. We can build a square off of a square. If you had laid them all out this way, you couldn't get a square because you started out with a rectangle. So here's our 4x squareds. And now, just like before with complete the square, you're going to take these 8x and you're going to lay them out so that they're alongside of these. So you notice that instead of dividing them by 2, like with the original complete the square where they were laid next to the x squared, this time you divide them by 4. So in order to see how many c's we need, which we only need 4 little c's to get there, we take this 8x, take that b value, 8, divide it by 4 this time. Okay? So we've got 1, 2, 3, 4 sides, and we squared that answer to get the c. So 8 divided by 4 is 2, 2 squared is 4. There's our 4 pieces. So that's how you complete a square if it's not a 1 there. You do need to get it to 4 so that you can build your square. So here we go with solving this problem. We solve it by completing the square. So since this is a 4, we have to take 8 divided by 4 squared. That will be 4x squared plus 8x plus blank. 2 squared is 4. Now that'll complete your square right there. But to keep it still equal, you would go minus 4 out here, equals 21. Now, this is your complete square. So you go 2x plus 2 squared. Now, if you are to multiply that out, 2x plus 2 times 2x plus 2, you should get this. Let's just try it out. First times first would be 4x squared. For outside times the outside would be plus 4x. Inside is plus 4x. And last is 4. These 4x's become 8x. So it does equal that. So this, the way I got it in my head is I took the root of this, the sine of that, the root of that, just like you've done when this is a 1x squared. Now we have minus 4 equals 21. We want to go ahead and solve this for x, so we have PIMDAs. Going up to PIMDAs, nothing's being added or subtracted outside. Oh yes, there is, minus 4. So we add 4. And we get 2x plus 2 squared equals 25. Now our next step. Our next step is take the square root. Take the square root plus or minus. That'll cancel that. Ugh. Snap. Keep forgetting to do that. Okay. Take the square root of that, plus or minus 5, equals 2x plus 2. At this point, you need to split it into 2 parts. 2x plus 2 equals positive 5, or 2x plus 2 equals negative 5, and I'll just use that one. Now we subtract 2 from each side. We get 2x equals 3. Subtract 2 on that one. We get 2x equals negative 7. Last step, divide by 2. So we get x equals 3 halves, or x equals -7 halves. Okay? This one just challenges you a little bit more where it isn't a 1 in that complete the square. So now you might get one like this and you go, I'd really like to complete the square, but it's not a 1, it's not a 4. Well, feel free to go ahead and multiply everything on both sides by 2. That would create 4x squared plus 12x plus blank to complete the square equals 10. Now we take half of the 12, divide by, not half, take 4, divide it into 12, and square it. This will be 3 squared is 9. Don't forget we want to subtract 9 as well. This part right here will be the perfect square. So we go 2x plus 3 squared minus 9 equals 10. Now we add 9 to both sides. Get the parenthesis alone. So we have 2x plus 3 squared equals 19. Take the square root. So we get 2x plus 3 equals plus or minus square root 19. Subtract 3, 2x minus, and subtract 3 from that side, it would be gone, equals -3 plus or minus square root 19. We can't actually do that because it's not a perfect square. Divide by 2, divide by 2. We can't reduce either of these, so we leave it as -3 plus or minus radical 19 over 2. That truly is two different options of answers, because you could go -3 plus radical 19 divided by 2, -3 minus radical 19 divided by 2. Okay, have a great day. We'll see you in class.